So use like bases to solve the equation. All right, so last thing I really want on these types is some kind of fraction, like this one is. So I'm going to change it into a not a fraction. Is I would be looking right now to reciprocate this, which would really make it 3 over 1, but I'm just going to show it as 3. Now, we can't just do this arbitrarily, right? There's always something else that has to be affected if we're going to just do things. Kind of like we do with principles of equality, and the only thing I got to do is make that 3 an exponent of -1, and of course that's to the power of x, which allows me then to just multiply the exponents, which then makes it 3 to the power, I'll even show it as -1x. Now this equals 81, but since I got this equal to 81, I'm going to look to now start factoring 81 as with bases of 3, right? So I'm just looking to see if I can divide 81 by 3. Let's see if this works. 81 divided by 3, yeah, that'd be 27. Now, by the way, in the past, I've usually circled these when they're prime. I'm now looking for a very specific base, which is, so even if this wasn't prime, I would be circling, okay? So 27, we can split that up between 3 and 9er, and then 9 splits up into 3 and 3. Okay, so really 81, it doesn't have to be shown as 81, it can be shown as 3 to the power of 1, 2, 3, 4. 3 to the power 4, and this equals the base 3, but to the power of, again, I'll show it as -1x. Okay, well, with this, now that the bases match as 3's, I'm looking at just the exponents, -1x and 4, and I just make, if I could make these equal to each other, then I'll get the same value out of my two exponentials, two expressions there. I just have to divide both sides by -1. Okay, so that tells me that x would have to be -4 in order for that to be true. Let's see if it does. Now, we already know that this value is 81, but what is 1/3 of the power of -4? It's 81. So we now know that this is the actual solution to our original equation. Just like we've seen in the past, whatever values of x that you use, they need to make the original equation a true statement. And this one does.